It's been over 50 years, half a century, but finally, humanity is sending astronauts back to the moon. We're talking about Artemis II, a mission that's not just repeating history, but building a whole new future in space. So let's dive in and see what makes this flight so incredibly important.
Think about that statement for a second. We're going back. It sounds like something out of a movie, right? But it's real. The gap between the last Apollo mission and this one, it's the longest we've ever gone without pushing beyond low Earth orbit. And that is all about to change.
All right, so who are the brave folks making this journey? Let's meet the crew and get a handle on what exactly they're setting out to do. Okay, here they are. The 4 astronauts carrying really the hopes of the world on this 10-day flight. You've got Commander Reid Wiseman, pilot Victor Glover, and mission specialist Christina Koch from NASA. And what's really cool, they're joined by mission specialist Jeremy Hansen from the Canadian Space Agency. This really is an international team effort. You know, this quote from the pilot, Victor Glover, just hits it perfectly. The Earth is quite small and the moon is definitely getting bigger. I mean, can you imagine that feeling? As they travel more than 230,000 miles away, that little blue marble we call home just shrinks and shrinks, while their destination, it just fills the whole window. But here's the thing you have to remember. Artemis isn't just Apollo 2.0. It's not about just repeating what we did in the 60s. It's about honoring that legacy, for sure, but aiming for something way, way bigger. And that's what makes this whole thing so fascinating. And this slide just nails the difference. Apollo, that was a sprint. Get there, plant a flag, grab some rocks, come home. Flags and footprints. Artemis, though, that's a marathon. The goal isn't just a visit, it's to build a long-term sustainable human presence on the moon. It's the training ground for our next giant leap, to Mars. So, to pull off a mission this ambitious, you can't use 60s tech. You need a 21st century spacecraft. And that's where the Orion capsule comes in. Let's take a look at this incredible machine and see why it's such a massive leap forward from what the Apollo astronauts flew. First off, just simple elbow room. Orion has 30% more living space inside than the old Apollo command module. And that might not sound like a lot, but it is huge. Apollo was built for, at most, a 14-day trip. Orion is designed for missions of 21 days or even longer. That extra space isn't a luxury. It's absolutely critical for keeping the crew healthy and sane on those long journeys. Okay, now get ready for this. The leap in computing power is it's hard to even wrap your head around. Orion's flight computers have 128,000 times more memory than the single computer that took Apollo to the moon. Just let that sink in for a second. 128,000 times. And it's not just about storage. The processing speed is 20,000 times faster. So what does that actually mean for the astronauts? Well, it means the spacecraft can do a lot of the flying itself. It can automate complex procedures, adjust its course on the fly, and handle emergencies with a level of safety that was pure science fiction back in the Apollo days. It lets the crew stop being just pilots and start being what they're there for, scientists and explorers. This table really puts it all into perspective, doesn't it? I mean, look at the difference. More crew members, longer missions. And this is a big one, power. Apollo ran on finite fuel cells. When they were out, they were out. Orion has these big renewable solar arrays. And the flight control. Apollo was all switches and dials, totally manual. Orion is a modern glass cockpit, like a brand new airliner. It even has a proper galley, exercise equipment, and a little more privacy. It's a whole new world. And the upgrades go even deeper. I mean, think about what it actually takes to keep people alive out there. The life support system alone is pumping out hundreds of pounds of water and oxygen. You've got 33 different engines for super precise steering. And to protect against that brutal deep space radiation, all the electronics are specially hardened. They're even using modern composites and 3D printed parts to make the whole thing stronger and lighter. It's just next level engineering. Okay, so here's the key thing to remember about Artemis II. This isn't the grand finale. It's the ultimate test drive. This whole mission is about wringing out this new spacecraft before we ask it to do even more complicated things. So, let's look at the 10-day flight plan for this historic trip. All right, here's the game plan. After that incredible launch, they'll spend about a day in a really high Earth orbit, way above the space station, just checking out all the systems, kicking the tires, so to speak. Then on day 2, there's a really important test we'll talk about. Day 3 is the big one, the burn that flings them towards the moon. They'll swing around the far side on day 6, get some amazing views, and then it's a 4-day trip home for a splashdown on day 10. So what's that big test on day 2? It's called the Proximity Operations Demo. Basically, Commander Wiseman and Pilot Glover are going to turn off the autopilot and fly this thing by hand. They'll use joysticks to fire the little thrusters and see how this 13-ton vehicle handles. Does it drift? Is it responsive? It's a crucial check to make sure they can actually fly it manually if they ever need to, before they commit to that long journey to the moon.
And during that flyby, man, the crew is going to get a view of the moon that no human has ever seen before. Because of their unique path, they'll be the first people ever to see the massive Orion Basin. It's this incredible feature that looks like a giant bullseye on the moon's surface with their own eyes. Not through a telescope, but right there, out their window. But even as they're preparing for these just awe-inspiring views, they are testing every single system on board. And some of those systems are a little more down to earth. The crew actually reported some issues with the toilet pretty early on. And as NASA's Debbie Court said, space toilets are a universal challenge. It's kind of funny, right? It just proves that even when you're reaching for the stars, some problems are still very, very human.
All right, let's pull back for a second. Let's look at the big picture. This one single flight is part of a much grander plan. So why does testing this one spacecraft on this one mission matter so much?
Because it's all about taking it one step at a time. A very deliberate process. Artemis I, that was the uncrewed dress rehearsal, and it went beautifully. Artemis II, this mission, is about proving that humans can actually live and work in this vehicle in deep space. Next, Artemis III will practice docking in lunar orbit, and then Artemis IV will finally land astronauts back on the surface to start building that permanent base. See? Each mission unlocks the next one.
And one of the most incredible new technologies they're testing is communication. I mean, we all remember that grainy black and white TV from the Apollo missions, right? That was being sent at about 10 kilobits per second. Now look at this chart. Orion's new laser comm system can blast data at up to 260,000 kilobits per second. That is an insane leap. It's fast enough to stream 4K Ultra HD video from the moon to us here on Earth almost in real time. We are going to see this journey in a way we've never been able to before.
So the takeaway here is pretty clear. This is a total paradigm shift. It's not about quick visits anymore. This is about long-term exploration, about doing real science, and about building the infrastructure for humanity's future in the cosmos. This is definitely not your grandfather's moonshot.
Artemis II is the mission that proves the ship is ready, that the crew is ready. It's the essential test flight that makes everything else possible. So as we watch these 4 astronauts loop around the moon, the real question isn't just about where they're going, it's about where they're paving the road for all of us to go next.